So this is the last little bit of section 2.1 that we started last time. This is writing the transformations. And this is the transformation form that we talked about a few classes ago. And this transformation form actually has a different name. The name is called the vertex form. And that is called the vertex form because looking at this equation, I can find the vertex of the parabola. So here's a parabola, kind of. The vertex would be that one point right in the center on the line of symmetry. And looking at this equation, I can see the vertex right away. So the vertex is formed by starting at 0, 0, moving either left or right, moving up or down. So we can find that by looking at the h value that indicates the horizontal translation left or right, and then the k value indicates your vertical translation up or down. Remember, the h value is horizontal, so it's going to be opposite. So if it says minus h, we're actually going to go right. But the k value is the same. So if it says plus, I will go up. If it says minus, I will go down. So we can look at this equation and find the vertex right away. So we call it vertex form. So let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. We're going to write the rule for G and identify the vertex. Okay, so we have the words followed by, and we have the words followed by. We're going to do this in 2 parts. We're going to first do the vertical stretch by a factor 2 and a reflection in the x-axis. We're going to do that by itself first. So a reflection in the x-axis, a vertical stretch by 2. Both of those are vertical transformations. Reflection in the x-axis, remember if you pull out an x-axis and you take an object and you reflect it up and down, that is a vertical reflection. So both of those are going to go on the outside. So we would take our original function, there's my original function, f of x, and we are going to go on the outside of that f of x, and we're going to multiply it by negative 2. So what is f of x? What equation tell me f of x is? It says it's somewhere in the sentence. What is f of x? By the way, Ella, welcome back. So happy to see you. How was your vacation? Yeah, okay. Jaden, what's f of x? Yes. So instead of writing f of x, I'm going to write x squared in that spot. Sierra, do I need those brackets? So if I'm multiplying negative 2 times x squared, I can just multiply them together and get rid of the brackets. Here they are, negative 2 x squared. So there's the first part. The second part now says translate 3 units down. So my second part, translate 3 units down. So I'm going to take that first part, and I'm going to translate 3 units down. That goes on the outside of the equation. You see I've showed this is the equation here. That minus 3 goes on the outside of the equation. Yes? That's a good question. Do I need the brackets? No. I have them there because I want you to get in the habit of having them there just in case they are needed. Because where you guys made mistakes on that last quiz, you weren't thinking about things like this. You're just sticking a negative 3 in there. Okay? So I'm putting them there, and then I say, if I don't have them, does that really affect anything? No. So I'm going to go ahead and drop them now. And that should be my g of x. So this is the rule. That's the equation. That's the rule. See how it says write a rule? And then we have to identify the vertex. So the vertex is the h and the k. As an ordered pair. So we're looking for a horizontal translation and a vertical translation. Anything horizontal would be squared. Is there anything besides the x being squared? No. So we do not have a horizontal transformation. However, there is a number we put in h. Even though there isn't one, there is a number we put there. When we write an ordered pair, but it doesn't go anywhere, 0. Good job, Jackson. All right, and then we do a vertical translation. Is there a vertical translation? Yes, Aya? Right, so I'm going to put a -3 right here, and that tells me the vertex of this equation, if I were going to graph it, which I'm not going to, would be at 0, -3. So that's where the vertex would be. With this parabola, would it open up or would it open down? Sophie, would this parabola open up or would it open down? Why? Because of the reflection in the x-axis, this one would open down. Yeah, that's as exact as I'm going to get right now. All right, example 4. Let the graph of G be a translation 3 units right and 2 units up, followed by a reflection in the y-axis of the graph of f of x equals x squared minus 5x. And we're going to write the rule. We're not doing the vertex for this one. We're just going to write the rule. Okay, so I'm going to look for the words followed by. I'm going to look in front of the word followed by. So there's followed by. And in front of it, a translation 3 units right and 2 units up. So 3 units right would be f of x minus 3. 2 units up would be on the outside of that plus 2. So now I've written that in function notation, like a formula. When we have the blue part, this means to replace x with parenthesis x minus 3. And then the red part is put a plus 2 on outside of function. Okay? So inside of the function, I'm going to replace x with the x minus 3. On the outside of the function, I'm going to just put a plus 2. Does that say outside? Did I do good enough? Outside. Should I rewrite that word? Outside. I have people in here that are learning our language and learning math at the same time. I don't want to be confusing. Outside. Okay. So the equation is, I'm going to rewrite it because I scribbled all over it. X squared minus 5x. There we go. So the equation is that I need to replace all of my x's with a parenthesis x minus 3. And I've got x's in 2 different places. So I'm going to have a parenthesis here, x minus 3 squared, minus 5. And then I'm going to have a parenthesis here, x minus 3. And then on the outside of that, plus 2. You see how I put the plus 2 on the outside? How I replaced my x's with the x minus 3s? So now this followed by, we can do that now or we can simplify first. It doesn't really matter what order we do them in. We could do it now or we could simplify first. I tend to like to simplify first. So that's what I'm going to do. When I say followed by, I usually simplify it. So right now, I've got some stuff to multiply. The first one is going to be something we have not reviewed this year yet, but it is from Algebra 1. When you see a squared on a binomial, when you see two terms squared, that means you have to do x minus 3 times x minus 3. And to do x minus 3 times x minus 3, there's different methods you could do, but it's the distributive property. A lot of people in the past, when I've done this, like the box method. Do x minus 3 and x minus 3. This is not actually my go-to method, but I just know a lot of people like this method. It's a visual method where we're finding, basically like finding area, but we're doing it in smaller chunks. So in this first box, if I do x times x, that's going to give me x squared. In this second box over here, if I do x times negative 3, I get a negative 3x. Down here in this box, I'm going to do x times negative 3, so negative 3x. And then in the far box, in that far bottom right, I do negative 3 times negative 3, which is positive 9. Then we look for like terms that we could combine, and I can combine these like terms. So I get x squared minus 6x plus 9 for that answer. So the other way of doing that, which we're going to spend more time on doing that a different day, but the other way to do that would be to do like x times x, x times minus 3, negative 3 times x, negative 3 times negative 3, if you remember that method from before. Either method's fine. I'm just going by, most of my students actually like this one. The other part, we have to multiply this negative 5 times x minus 3. And again, we can distribute. Or you can use the box method for that as well. You would have negative 5 and then x minus 3. I made a really big box for that one, sorry. So it would be negative 5x, and that would be positive 15. So you could do it either by distributing or by doing the box method. Either way, we should get negative 5x plus 15. And then we still have that plus 2 on the outside. So when I get rid of the red brackets, when I plus 2, does it just like stay there by itself? Do I just get rid of the brackets, or could we do something with that plus 2? Ari, what can we do with the plus 2? To where?
I got it to the 15 and the 9.
So would I add it to 15 and add it to 9?
No, just to...
So we're just going to combine like terms. So that's one reason why, like, sometimes I have brackets, because sometimes we will distribute. Sometimes we don't. We just don't need the brackets anymore, and we'll combine our like terms. And those are times that you guys have to be able to tell the difference between. So we're going to combine our like terms. 9, 15, 2, 17, 26. Anybody else do that math? Double check me. I make mistakes easily. Hauling you awake. Are there any other like terms that we could combine besides the numbers? I think it's 26. Nobody's arguing with me. I hope I'm right. I'm making a video here. Brooke, bless you. Is there anything else I can combine? The x's, I've got a negative 6x and a negative 5x, so that gives me a negative 11x. Oh, man, that took a while. We're done, right? No? You don't know. Okay. Jaden?
I think it was 24.
I don't know. 15 and 9 and 2. Did you do the 2? Okay. All right, so I've got 11, or x squared minus 11x plus 26. I'm just going to bring it up here so I can see it again. X squared minus 11x plus 26 because I'm not done. I wanted to be done, but I'm not done because when we were reading the question, we only did followed by. We still have to do the reflection in the y-axis. Reflection in the y-axis. Reflection in the y-axis. Is that a horizontal or a vertical reflection in the y-axis? Horizontal or vertical? Is this the y-axis? Is this? Oh, I almost dropped that. That would have been bad. Y-axis? Y-axis? This is a, what kind of transformation? Jackson. Horizontal. Oh, I didn't say you were wrong.
Oh.
Nobody else was answering, though. What direction is this, people? Do you guys want to have fun in here or be bored every single day? Your choice. I know we have to get through the content. Like, we can't not get through the content. You can, like, make fun of it. You can make fun with it, or you can sit there like this. It's your choice. So this is a horizontal, so that means we're going to replace x with, we do parenthesis, reflection is negative x. We're going to replace x with negative x. And we're doing it to this equation right above. So I will have parenthesis, negative x, close parentheses, squared, minus 11, parenthesis, negative x, close parenthesis, plus 26. So I replaced x with negative x. Simplify one more time. What is negative x squared? Tessa?
X squared.
Yes, it is x squared. Anytime you square a negative, it turns positive. Then we've got minus 11. Multiply that by negative x. Jacob? Positive 11x plus 11x. And then nothing happened to the 26. So that should be our g of x equation. Why can't I find the vertex? Why can't I find the vertex in this form? This is the answer. Why can't I find the vertex in this form? Let's scroll up. What's vertex form? Some number outside parentheses. X minus h squared plus k. This is a horizontal translation. This is a vertical translation. That's how you get your vertex. Why? I'm just going to copy down that answer we just had. Why can't I find the vertex for this one? I think that's what the answer was. Why can't I find the vertex for that one? Ariana?
There's nothing that like shows the x form, so like nothing indicates the horizontal translation.
Right. Well, there is something squared. So if I were looking at that, I would think the vertex would be at 0 because there isn't a translation. There is like a plus k kind of. It's a 26, but what's this thing in the middle? 11x. is there an x term in vertex form? An x by itself? You see an x term sitting here by itself, not being squared, but just by itself. Do you guys see that? This is not vertex form. You cannot do vertex from this form. You cannot do vertex from this form. You cannot. You can, but I haven't taught you how. You can't just grab numbers and find the vertex from this form. It's a longer process. And I'll show you on Desmos. That's different class. Am I typing in the right equation, by the way? Is it this? So if I actually went and found the vertex, see how Desmos is so nice? It allows you to just click on the vertex and there it is. The numbers did not involve a 0 and a 26 like I would have thought. There's not even 11 in there. Actually, there kind of is an 11 in there. It's just hidden. So if it's in a different form, you can't find the vertex until I teach you how to find the vertex, which is soon. All right, almost done. Try another one. Let the graph G be a vertical shrink by a factor of 1/2, followed by a translation 2 units up of the graph of f of x equals x squared. Write a rule and identify the vertex. I want you to try it on your own. So if we have a vertical shrink by a factor of 1/2, and then a translation followed by translation 2 units up, I'm going to start with my x squared, my f of x. I'm going to start with f of x. And to that f of x, we're doing a vertical shrink by a factor of 1/2. I don't have to change anything for vertical. This goes in front as 1/2. So we have 1/2 x squared. Can I just go ahead and multiply those together without the brackets? So we've got 1/2 x squared. Now, the second part, why won't you change color? The second part, we're translation 2 units up, and put that on the outside. Do I need these brackets here, or can I just put them together? I can just put them together. Oh, that was so messy. I'm so sorry. Then we need to identify the vertex. So we look to see what is being squared for the x part. This one's just like the first example that we did today. Ella, can you tell me the x part? What is being squared? What number is being squared? Nope, half is not being squared. The squared is only on the x. So other than the x, is anything being squared? So then 0. And then the vertical translation, Gennaro, what's the vertical translation? Up or down? What number? What number? Positive or negative? Positive, does that go up or down? Up, 2, plus 2. So we have our vertex. All right, here is the same kind of question, but it's to a real-life example, so we've got some reading to do. The height in feet of water spraying from a fire hose can be multiplied by that equation. You guys, I don't know if you've ever seen water come out of a hose. There's my hose. There's my water. Did you know it made a parabola? Because of gravity, if I'm shooting something up, it's eventually going to slow down and come back down. Gravity makes lots of parabolas happen. It's kind of cool. So x in this function is the horizontal distance in feet. So side to side is the x. And the height is the h, so how high it goes is h of x, that would be our y. This is the height. The crew raises the ladder so that the water hits the ground 10 feet further from the fire truck. Write a function that models the new path of the water. So it was here. It was here, and then the crew races the truck, and now the water is 10 feet away. Write a function that models the new path of the water. What's changing? What's changing in this? Jackson?
How far the water goes?
Because what changed to make it go?
The height of the truck.
Right, we raised it up so that hose is starting higher up. So it has like further to go down, basically. That's what's happening. That's because we went up higher. So really, we're trying to figure out let's see here. This was x, and now it is what? And now it's x plus 10. Right? It was x, now it's x plus 10. So if we take the equation, oops, I totally messed that one up. It's not going to be x plus 10 though. My bad. What's it going to be? Shouldn't be plus. If I put it in the equation, we got to do the opposite. So I should put in minus. Right? Because if it's moving right, then it, I mean, that really just depends which way my hose is facing, but I always face left to right, so. And then we could simplify that. I'm not going to take the time to simplify it. And then I think this is the exact same. So we're going to move on, okay? On your modules, there is a lesson 4 assignment, and this goes with rewriting transformations. How much time do we have? Let's do about 10 minutes on that assignment. We're not going to have time to get up and move around the room and talk for 5 minutes and then get started. So go ahead and open that in Cami. Work for about 10 minutes on that assignment. See what questions you have. And really, you know what? I want you to do number 1 last. Because I want you to go through and do more of this. If you don't get number 1, I'm not even going to worry too much about it. I think I was going to cut number 1 out, but I forgot to. But start with the transformations, and then really we want to spend the most time on 5, 6, 7, and 8, and 9 and 10, because those are the ones where that's the content that we were really going over today. If you can get number 1, that's great, because that shows me that you really understand what's going on. If you can't get number 1, that's okay. We'll go over it. Got someone? I guess so. I guess the do. Oh, it's compounded. Thank you. What? Oh, yes, not. Compounded. But thank you. See if they screwed up this time. They don't seem very excited about somehow. No? Lauren? Thank you, Lauren, for that look. If you're going to do something right now where you could ask me questions, then this would be the best one. You're not going to have time to get through this whole thing right now. But those are the ones we were just practicing. That's where people tend to make the most mistakes, like on that test.